Moonshine Life Recipes Group. Understanding enzymes. Homebrewers find this question confusing, which is hardly surprising, since many commercial brewers don't appear to truly understand it either. It is important to think of the mash as two distinct operations: conversion of the solid malted barley into a liquid extract, and recovering that sweet wort from the spent grains. This article will discuss mashing enzymes, which convert the starch in malt into soluble sugars. By understanding and manipulating enzyme activity, an all-grain brewer can control the fermentability of his wort. What are enzymes, anyway? First and foremost, enzymes are proteins. They are a specific type of protein with an important role. They catalyze biochemical reactions, which means that they enable a reaction to occur quickly and at the temperature of living organisms. They act on small molecules to join them together and make them larger. They take large molecules and break them up into smaller ones, or they rearrange molecules into something different. Each biochemical reaction is catalyzed by a very specific enzyme. For example, maltose is created by joining two glucose molecules, and this is done by a specific enzyme. A different enzyme is responsible for breaking the maltose back into two glucose molecules. Maltose also can be created by breaking a two-molecule chunk off a long chain of glucose molecules, and this is done by yet another enzyme. Being a protein, enzymes are made of several thousand different amino acids selected from the 20 naturally occurring amino acids joined together. This chain is then folded and coiled to form a specific shape. This shape is suited to the specific job the enzyme must do, and so it is important. However, the shape is relatively fragile and can be damaged by excessive heat or agitation, or chemical attack, which will render the enzyme unable to catalyze a reaction. This is called denaturing the enzyme, and once the structure is destroyed, rarely can the enzyme be renatured. The molecule the enzyme acts on is called the substrate, and the enzyme is usually named after this substrate, with the letters ACE added. Beta-glucanase acts on beta-glucan, and alpha-amylase is one enzyme that acts on amylose, a component of starch. The rate at which a reaction occurs is affected by temperature, and enzymes catalyze reactions more quickly as temperature increases. But they also are denatured by heat, and reach peak activity just before they are destroyed. Mashing enzymes from A to B. In a brewer's mash we are concerned with the activity of two main enzymes, alpha and beta amylase. Alpha amylase is the enzyme responsible for breaking large, complex, insoluble starch molecules into smaller, soluble molecules. It is stable in hot, watery mashes and will convert starch to soluble sugars in a temperature range from 145 to 158 degrees Fahrenheit, 63 to 70 degrees Celsius. It requires calcium as a cofactor. Beta amylase is the other mash enzyme capable of degrading starch. Through its action, it is the enzyme largely responsible for creating large amounts of fermentable sugar. It breaks starch down systematically to produce maltose. Beta amylase is active between 131 and 149 degrees Fahrenheit, 55 and 65 degrees Celsius. But like all enzymes, its activity reaches a peak, declines, and then drops precipitously as temperature increases. The rate is also dependent on the amount of enzyme present. It takes time for all of the enzyme to be destroyed, but what is still intact works very quickly. So as the mash temperature approaches 149 degrees Fahrenheit, 65 degrees Celsius, beta amylase is operating at its fastest rate, but it is also being denatured. This may seem trivial, but at these higher temperatures the denaturation is so rapid that the enzyme is mostly gone in less than 5 minutes. Also, in a homebrewer's mash tun, where the grain may be poured into very hot water, the exposure to very high heat for the few seconds before the mixture becomes homogeneous may work to destroy the fragile enzymes. This means that, in a practical sense, the manipulation of beta amylase activity can be utilized to control the fermentability of the wort. If the mash is allowed to stand at a temperature that favors the action of beta amylase, then a greater proportion of the sugars extracted from the malt will be maltose and hence the wort will prove more fermentable. In my commercial breweries, I found that changing the mash temperature from 149 to 156 degrees Fahrenheit, 65 to 69 degrees Celsius, raised the beer's terminal gravity from 1.008 to 1.014. This is a significant difference. Enjoy! Moonshine Life Recipes Group.